Welcome back everyone to the third workshop that we are doing about game development with Unity. So I'm just gonna do a quick recap of what we have so far, of our progress so far. So currently we have our player, we have the background to our game, and we can move our player around using the arrow keys, and we have the player look at the mouse when we move the mouse. So there's a few things that we need to fix here first. The first thing is the trailing effect that we added last week. So if you recall, we added the particle effect for the trail, but we did not configure the material correctly. So we're having a glitch here. And also, if we move a player and all the way to the right, in this case, the player just gonna go off screen, and if we move him back, then we can get him back. But the behavior that we want is so that when the player move to somewhere around here, they will not be able to move to the right anymore. So, you hit like a barrier. So that will be the things that we are going to fix first. So let's talk about the trailing effect. So here we have the trailing effect. It's a particle system, and if you recall, last week we assigned a material to it. We call it trail, which is here, and the shader of the material that we assigned to it was particles standard surface, which is not the right shader if we're doing 2D sprites particle, because this is for like 3D particle. So we want to change that. So what we can do is click on the drop down menu here and go into sprites and default. So this will give us the default sprites shader for the material, so that it will render the trail effect correctly. So if I move it around here, you can see that the trail now renders our sprite correctly on the screen. So that was a very easy fix. The next thing that we want is we don't want our player to move like off screen, so we want to confine our player in like this space here, and we can do that using colliders and invisible barriers. So if you've ever played any games, you might have run into like invisible barriers that stop you from running out of the map. So that is exactly what we're doing here. So the first thing to do is select our player, and we want a player to collide with the barrier. So we need a component for that. So quick recall, component is attached to an object, and the components define the behavior of that object. So I'm going to add a component, and what I want here is a collider. So I'm just going to search for it. It is a box collider 2D. Box collider is for 3D colliders, so I'm going to add the 2D version of it. And if we zoom into our player, there's a very thin green outline. So this outline shows us that yes, we did indeed added a box collider to our player object, and this is where the collider margins are basically. So we added a collider to our player, but we also need the invisible barriers themselves, right? So we need 4 borders at 4 directions here, and we can just do that by creating right click in the hierarchy, create an empty object. So I'm just going to create like border left, like this. Let's reset it. And so it is now an empty game object. We don't want any sprites because it's an invisible barrier. So we don't want the game to render anything, and we don't want rigid body or physics or anything. we just want the collider itself. So I'm just going to add the component, and again, box collider 2D. And if I move this border a little bit here, yeah, and we see that we have our collider, and it added a box collider, but the size of it is not what we want, right? We want a collider that spans across the height of our map. So if we look at the box collider, here we have our size in the x-axis and the y-axis. So we can just expand, or we can just increase the y-axis. And if you look at the scene view, you can see that the size of our collider is actually increasing. So that's what we want. So yeah, let's make our collider size y about 24, and we want to move it right to the edge of our map here, which is about 23, 22, 25. Yeah, that looks good. So we added a border to the left of our map. Now, if we try and run our game, we can see that we no longer can cross that left border because we added a collider there. So if I try to go all the way to the left, you can see that I can't anymore. So that is a quick fix to our problems. So I'm just going to duplicate this. So Control, you select the object, border left in this case, Control D to duplicate it. I'm going to rename it to border right, and it will be on the opposite location. So 22.5, perfect. And we also want the border at the top and the bottom of our map. So let's change that. So duplicate border right, border top. X will be 0, and this is, so we want to expand our x-axis, the size of our x-axis, and we want to reset a y to 1. So expand the x-axis to about there, 44. Yeah, that sounds about right. And this is border top, so we're going to move it up a little bit here, about 12.5. Perfect. Again, duplicate this, and we have border bottom. Boom, and there we go. So now we have the top and the bottom and the left and right, so the player can no longer move out of the map that we have drawn here, which is what we want. So now that's out of the way. Let's talk about, like, we have a player and can move around and can look at our mouse. Now we want to actually have a bullet and want a player to actually shoot the bullet out of shoot that bullet from the ship here. So the first thing that we need to do is creating the bullet object itself. So just like creating any other objects, we're just going to right click on the hierarchy, and I'm going to create a 2D sprite, and I'm going to select any sprites here. I'm going to bullet because we have our sprites and it's just a square for now, and we have a sprite renderer component, and the sprite that is rendering is selected is set to the square sprite. So we have a bullet sprite that I will just drag and drop into. So we have a bullet sprite. It's under sprites and others, and the file name is called single bullet. So you can just drag and drop it onto the sprite field of the component. Now we're having a quite a similar situation with our player object previously, like 2 workshops ago, that the bullet sprite is actually rendered behind the background. So we're just going to go into the sorting layer here, and we're actually going to add a sorting layer, and we're going to call this layer objects. And the object layer will be rendered between the background and a player. So the background will be at the bottom, the player will be at the top, and the objects layer will be in the middle. So we can just drag this objects layer and put it there. Back to our bullet, and let's select our objects layer, and there we go. So we have a bullet sprite. Now what we want is we want our bullet to fly like really fast, right? Because that's what bullets do. So in order for that, we're going to need rigid body, because that's what we're using here to control, to add movement to our player. So our player has a rigid body component. So we're just going to add a rigid body to our bullet. Alright, so it's a dynamic, and we change the gravity scale to 0, the same way we did with our player. Gravity scale is 0 because we don't want the bullet to fall down on the screen due to gravity. So there's that. And yeah, that should be it for now for the components. So in order to make the bullet actually like fly away, we need to do that through scripts. So let's do that the way that we have been doing, and go to our scripts folder in the project panel, right click and create a C# script. And I'm just going to call this script bullet. So Unity will create and compile the script for us. Let me see, and I think it's done. And we're going to attach the script as a component to our bullet object right now. So okay, it's compiling. So we go to our text editor, and we can see that the bullet scripts is added to our project. Let's go back into Unity. Yes, it is finished compiling. I'm going to drag and drop the bullet onto the inspector with the bullet object selected, and let go. And we have a bullet script attached to our bullet object. So let's get into coding the bullet script. So the thing that we want our bullet to do is always sort of fly forward, right? And so the first thing that we need to define is like the velocity of our bullet. So I'm going to create a float here, private float velocity, and velocity is just like how fast will the bullet travel through the world, and I'm going to set it to something like 40. And we also need a direction for which direction is the bullet flying towards. So that is a vector too. So it's a vector with like an x and a y value that represents a direction. So private so I'm going to call it current direction. Yeah. And we also need, so if you remember our player movement, we need a reference to our actual rigid body to the component to be able to move our player. So we're also doing the same here, that we're going to need a reference to the rigid body, the bullet's rigid body component. So just do it right here. And so and let's make our bullet fly. So what I'm going to create a function and bullet fly. So how do we make the bullet fly? Well, it's actually like the same as how we make our player fly, but now instead of getting the direction from the user's input, we just set the direction ourselves. So let's go in here and let's say rigid body 2D dot move position. So that's the method that we use to make our player fly. And rigid body 2D dot position. So that's the current position of our rigid body plus. So this is like the position that we're going to move into, and it will be current direction and times the velocity, so how fast the bullet is moving, and we also need to times that with time dot delta time, so that our bullet doesn't move like so fast out of the screen. And so we have our fly function. We also want to call our fly function. So we always want the bullet to fly, so we're just going to call it in the update method. And if you see in here that we have a current direction vector, but we didn't set it to anything, so it will default to like 0, 0. So I'm just going to put like a default thing here that says current direction is like the upwards direction. So there is actually a very handy value in Unity called vector2.up. So it is just like a shorthand value for the up direction, which is 0 in x-axis and 1 in y-axis. So current direction is up and velocity is 40. So if we save our script, go back to Unity, wait for it to compile. So because we're calling the fly function in update, it will always gonna fly, in this case, at the up direction. So let's go back into Unity, and so I'm gonna put the bullet somewhere here, like at the kind of bottom of our screen, so we can see its fly when I play the game. So let's play the game. Oh, we will actually get an error because I've got to reference the rigid body component in our inspector. So yeah, we do get an error here. So let's fix that. Here in our bullets, we make a reference here, to a rigid body, but we did not assign any rigid body to it. So it's none here. So that's why it's giving us an error. So I'm just going to drag the rigid body component. I'm going to drag the bullet object that has a rigid body component onto here and let go, and boom, now we have the rigid body component assigned from our bullet to the bullet script, right? So let's clear the errors and let's play again to see our results. Okay, that was very fast. The bullet just moved from the top and just move up and fly away from us. And so yeah, that is the behavior that we want from our bullet. So now let's get to actually like spawning a bullet, like shooting it when we click on the screen. And we're going to do that with our player, through a player script. So here's our player. Now when we click on the screen, we want to spawn a new bullet, like out of thin air. We want to create a new object, and we want to set the direction of the object to whatever direction that the player is facing. So if the player is facing like here, the bullet's direction will be in this direction as well. So the first thing that we want is actually like once we click on screen, like where do we spawn the bullet at? Like what position do we spawn at? So I can create an empty object of a player. I'm going to call it gun point, and this is where we will be spawning the bullet when we click on the screen. So there's a gun point, and I want to move it up a little bit so that it sits at the tip of our plane. So this is where we're going to be shooting from, right? So if you want to move it around, if you want to shoot from the wing, yeah, that's possible. But I want to shoot the bullet from the tip of our plane. All right. So let's go into our player script. So this is a quick recap. So a quick recap of what we have so far with the player script. We have fly, and we have the player to look at the mouse. So let's make a void shoot. So this function will handle our shooting functionality. So we added the gun point to a player. Now we need to make a reference to that gun point. So let's do that. So public transform gun point, and this point is where we're going to be shooting from. So let's go into our shoot function. And how do we spawn a new object in Unity? How do we create one? Well, there is a very handy function in Unity. It's called instantiate, and this instantiate function will create the object that we want. So the first parameter, so it will take the function will take a few parameters. So the first one is what object are we going to create in the instantiate. So we want to create a new bullet. So we need to make a reference to that bullet as well. So I'm going to do that up here. So public bullet. So this bullet here is going to be instantiated when we call the shoot function. So let's pass in our bullet object. And the second parameter is where do we spawn our bullet or the object that we set. So we already defined that in the we already have a position that we want to spawn in, and that is the position of our gun point. So gunpoint.position. And the final parameter is what is the rotation of the object that we want to spawn. And for now, we're just going to say quaternion.identity. So what quaternion is like, it is a special type, just like vector2 or vector3 in Unity, that handles rotation. And quaternion.identity is like the default rotation. So if you go to the Unity editor, we have the player rotation is 0, 0, 0. So that's what quaternion.identity is. So go back in our script here. So we spawn a bullet and we give it a default rotation, but that's not the rotation of the bullet, right? So what we want here is to move. So remember how we have a direction in a bullet. So we actually want to set that direction here to the current direction of our player, right? So this should actually be public because we'll be setting it from our player. I'm going to remove vector 2 up here. So we instantiated a bullet, and this instantiate function actually returns, if you hover, I hover the mouse over it, and it actually returns the bullet that we instantiated. So we can instantiate it and say dot current direction is the current direction of a player. So you just transform dot up. So we instantiate the bullet and we set the direction to our, so it's flying direction to our up direction of our player. So go back into Unity, wait for it to compile, and now when we like click on the, yeah, so that's something that, I forgot to handle, is the actual like input handling of once we click on the screen. So let's do that. So what we want is whenever we left click, we want to call the shoot function. So let's handle that in our update method. So, and there is a function in the Unity input handler that tell us when the mouse button has been clicked. So I'm going to put an if statement here, input dot get mouse button down. So this will return true whenever we click on the mouse button. And in here we actually want to pass in a parameter for like which mouse button that was pressed. So I'm gonna put in here 0, which is the left mouse button. So 1, I think 1 is the right mouse button and 2 is the middle mouse button. So I'm putting 0 here, and in the if statement we're just going to call the shoot function. So save that and go back into Unity, and now that we have the input handler in our update, we should be able to click and instantiate a new bullet in our game. So let's wait for it to recompile, and the first thing that we need to do that we forgot to last time is assigning the references. So the gun point is our gun point. So I'm just going to drag and drop it, and the bullet object that we want to spawn is a bullet here. So I'm just going to drag and drop it here. So let's play the game and see. So we see this bullet will fly up very fast, and whenever I click on the screen, we see that we instantiated a new bullet, and it's flying towards the direction that we pointed. But you can probably see the problem that the bullet's rotation is always like standing up like this, which is not what we want, right? We want the bullet to like rotate with our player, So let's go back into our shoot function, and we see that we instantiated a bullet and we gave it a quaternion identity, which is the default rotation. So we want to change this, right? So let's replace this with the actual rotation of our player. So which is transform dot rotation, and that should give us the behavior that we want. But so when we start the game, we don't want this bullet here to always be here and like fly upwards in a weird way, where we don't want the bullet here at all. We want to delete it. But if we delete the bullet from our scene here, as I just did, we go into a player, we can see that the bullet reference is missing, right? And well, I'm going to undo the deletion. We see that the bullet is now back. So what we want is a way to reference our bullet without it actually being in a scene, and we're just gonna spawn it whenever we want, right? And obviously, like what we can do is like move the bullet like here, to move it like out of the way, and now when we start again we don't see it anymore. But what I want to do is actually make this bullet object a prefab. So what is a prefab? So in Unity, a prefab is basically a reusable object that you can save in your project folder as a file in your project folder, and you can like in this case you can spawn it whenever we want without it actually being in our scene. So how do we make this bullet a prefab? Well, first of all, we want to create a prefab folder. So let's do that right now. Right click, create a folder for all of our prefabs. And so we have the prefabs folder, and all we need to do to make this bullet a prefab is dragging and dropping it onto our project panel. So if I let go here, you can see that we have a new entry in our directory named bullet, and the bullet here actually like turns blue. The text and the icon next to it turns blue. That tells us that it is now a prefab, and we can refer to it without it actually being in the scene. So if I just delete a prefab here, go into our player, we see that the bullet, yes, it is still missing, but we don't need the bullet in the scene anymore to actually refer to it. We can just drag and drop our bullet prefab in, and there we go. So if I play the game now, we can see that we can still spawn the new bullets without the other bullet being in the scene initially. So let's do that. Wait for it to load, and when I shoot, we can see that we indeed can spawn a new bullet, and the rotation of the bullet is now correct, so we can shoot different bullets out of our plane. That is the bullet shooting functionality. So let's see what we cover next. Let's talk about how to, like, when a bullet actually hit our player, what do we do then? Because we want a player to sort of take some damage, right? And decrease the health of a player, and when the player health like reaches 0, we want to like do the game over thing. So let's handle that. If we go to the player movement script, and let's add a field for our health. So it's going to be an integer, private int health. And we also want a field, we also want a variable for like the maximum number of health that the player can have. And since this value doesn't change, we can make it constant. So const int and call it max health. And I'm gonna say the max health is about 5, right? And so we want a function in our player for our player to actually take some damage, right? So let's make a function to do that. So this function is actually going to be public because we want to call it from other classes. So public void, and it's going to be take damage. And in here, the parameter, we want to pass in like int damage because we want to know like how much damage should the player take. So what should we do when we take the damage? Well, for now, let's just decrease the health. Health minus equal damage, right? And here we want to check if the health is less than 0, then, well, obviously the game is over, the player is dead. So let's do that. If health is less than equal to 0, then we're going to die. Oops. So I just made up a function here called die. We don't actually have this, so let's define that here. So void die. So what do we want when our player die? Well, obviously we want to destroy the player itself. So let's just do that for now. So destroy the game object. Right? And so now that we have the base functions for handling the damage and the death of our player, let's see. Oh, we have an integer for health, and we have a max health in our start method here. So recall, start is called before the first frame is updated. So update is called every frame. So in the start method here, we want to set the health to our max health value. So now when we start the game, the player will have a health of 5, and when the player takes some damage, the health will decrease, and eventually the health reaches lower or equal to 0, and the player will die. So there's that. But we have the functions, but we're not actually calling it yet, because what we need now for our player to take some damage is some enemies to shoot at the player, right? So let's create the enemies. So I'm gonna do like a quick explanation of how the enemies will work. So basically, we have in our sprites folder here, we have some ships, and ship 0 is our player. So what I want is the enemy can take the form of any of the remaining ships, and we're going to have some very, very simple AI that drive the enemy. So basically, it's just gonna move like randomly around the screen, and it's going to shoot at the player at random interval. So that's just very, very simple AI to drive our game. So let's start by creating the enemy object itself. So right click and create an empty game object. So let's call it enemy. And go into our scene, we see that we have our enemy here, and we want a sprite renderer, right? Because we want the enemy to be rendered on the screen. So let's add the component sprite renderer. And the sprite we will assign here is the ship 1. The sprite that we assign here is actually like a temporary sprite, because what we want is when the enemy is spawned, like when it's created, it will actually like randomly pick one of these sprites from 1 to 7 and we will change to that sprite. So that's what we want, but we're just going to assign like a temporary one here before we actually get to coding that. So we can see that again we have the same problem as is rendering behind the background, so we're going to add another sorting layer for our enemies. So enemies, and it will sit between objects and player. So back in our enemy objects, and let's select that sorting layer, and there we go. So we also want, because it's also a ship on this flying above this background, we also want the shadow to be sort of around our enemy as well. So I'm just going to add a 2D sprite here, call it shadow, and we're going to assign the same sprites, do what we did with the player object, that we assign the sprite and we set the color to 0 to black, and the alpha value to about 100, I think. And so the z value should be 0, so that is consistent across our objects. So let's move this shadow down. We can see, yeah, the alpha value should be higher. Let's see what our players. Right, it's rendering behind the background again. So I'm going to change it to enemies. And now that we have our shadow, and again, the like shadow positioning and everything is going to be like pretty much the same as our player. So yeah, -1, -1.5. So we're not going to have our gun point. Oh, do we? Ah, yes, we do. Yes, we also want to have a gun point on our enemy, so that's where our enemy is going to be shooting from. So I'm going to add an empty, and I'm going to also call it gun point. And I will also make it about at the top of our ship. So there we go. So we have the enemy object with the shadow and the gun points, just like our player. Now let's get into actually adding the components and coding the enemy. So first thing we need to do is, of course, adding the component. So it will be quite similar to our player. Again, we're also going to have a rigid body. We're also going to have we're not going to have plate movement. We're going to have a different script to control our enemy, and we're also going to have a box collider. Now, this box collider on the enemy. So let me add them as I speak. This box collider on the enemy would not be used for confining the enemy in the space, because we control the enemy through our enemy like AI scripting, so we don't have to worry about it going off limits. But what we want is when our player shoots a bullet, we want to detect that bullet hitting the enemy. So that's why we will add a box collider 2D opponent to our enemy, which is here. And yeah, so we have rigid body to control the movement of the enemy. We have box collider to detect the collision between it and the bullet. So the next thing to do is, of course, getting to code the actual enemy itself. There's something called a tag system. So if you look at the inspector of an object, so we have like the enemy the tag is now untagged, and so we will be assigning the tag to our objects, and then so when the bullet like hit an object, we'll be comparing like what object did it hit through the tag, right? So if it hit like an enemy with the an object with the enemy tag, so we will know then that we actually hit an enemy and not a friendly fire. So, and then we will damage the enemy, and if it hits like something that's not an enemy, then we don't damage it. To save us some time, I created an enemy script here. This is very simple, just the same process. Right click in the project and create a C# script and call it enemy. So let's go into our code editor, and we see that we have a new script for our enemy. Now, a quick recap on the behavior of our enemy. We only have one enemy object, but this enemy will be like randomly generated. So we will assign a random ship sprite, and we will also give it like a random amount of health within our restriction. And we also want it to move randomly around the screen, around the map. So let's go into our enemy script, and the first thing that we want to do is make a reference to the enemy like sprite renderer, so that we have so that we can change the sprite to other ships. So let's make that public sprite renderer, and I'm just gonna call it sprite renderer. And we also actually want a reference to our shadow sprite renderer, because it should be the same sprite as our enemy script, right? So go back into script, public sprite renderer shadow, right? And now what we want is we want to make a set of sprites so that the sprite renderer can choose whatever sprite it wants to set to. So let's make an array of sprite, not sprite renderer, sprite, which are these things down here, right? This is a sprite. So public sprite, and it is an array, and I'm just gonna call them ship sprites. And we want a function to actually set these sprites when we spawn an enemy. So let's make a function for that called void generate, and it will be very simple. We're just going to say the well, first of all, we have the list have an array of ship sprites, but we want to choose from that array one sprite that we're going to assign. So let's do that. Sprite. So this is the one sprite that we're going to assign. So this is let's call it assigned sprite, and it will be one of these things here. So how do we do that? Well, obviously it will be part of ship sprites, and here I'm going to give it an index. So the index of the array can be like 0, 1, 2, 3, but because we're like randomly generated here, we don't want to put like a number. What we want to put is random dot range. So this will give us a range, like a random number from a range, and the minimum of the range will be 0, right? And the maximum of this range will be the length of our sprites, right? So if we have like 7 sprites. So the maximum should be 7, but we want to we don't want to put 7 here, because what if we add more like sprites to the game? So what we want is ship sprites dot length. So that should return that should put the assigned sprite, a random sprite from the array. And now that we have it, we can just say sprite renderer dot sprite equals assign sprite. So we're setting the sprite of the sprite renderer, which, let's go back into Unity. If we recall, the sprite renderer has a sprite here, so we're setting that value to the assigned sprite. And we do the same thing with shadow. So shadow.sprite equals assign sprite, just like that. And we also want to give it like an amount of health, right? So just like we did with our player, so I'm just going to make an integer called health, and we also want this time not a constant integer max health, because our player's max health is always going to be 5. But what we want is like a range of health that we can like generate from. So for example, like if I create a vector2 here and call it like health range, right? It will be a new vector2, and it will be between 2 and 5. So basically what this means is that our enemy's health, like the max health of our enemy, can be anywhere between 2 and 5. So we also want to assign them. So let's go in our generate function and say health equals, we also want to randomly generate, so random dot range, and so this will be, the min value will be health range dot x, and the maximum value will be health range dot y. So it's giving me an error here because the vector2 value is actually like a float. So 2 and 5 here are actually floats, but our health here is an integer. So I'm going to want there's actually a special type in Unity called vector2 int that is very similar. So let's change here. That is very similar to a vector2. So it also has like an x and a y value, but it only takes like integer as their values. So we generated a random health value somewhere between 2 and 5, and so we also generate our sprite here. Let's call this function in our start. So start, and let's go back into Unity. Alright, so select our enemy, let me collapse it here, and I'm going to attach the script, the enemy script, to our enemy object, just like that. And we see here, we also don't want to forget to make the references. So sprite renderer, which will be the enemy's sprite renderer itself. So drag and drop the enemy into that. We also have shadow, so drag and drop our shadow into that. And we have an array of ship sprites. So that would be the ships right here, from 1 to 7. So there will be, this will be the size of the array, which will be 7. And we have, when I put 7 in here and I hit enter, I have 7 fields that we can put our sprites into. So let's do that one by one. So ship 1, ship 2, just gonna drag and drop these onto here. shift 4, 5, 6, and 7. There we go. So now that we have all the references ready, we can actually play the game now and see that the enemy sprites will be sort of randomly chosen between our sprites here. So we can see that it does. It's this green one here, so perfect. So the next thing that we want is we want movement to our enemy, right? And of course, when we talk about movement, we need a reference to our rigid body. So public rigid body. And we also want a sort of like a target position, because we're moving the let's see here, we're moving the enemy around on the map, right? So we want a target position, so for our enemy to move to, and that target position will be sort of randomly generated. So yeah, so that will be a vector 2, because it is a position which has an x and a y value. So private vector 2, and let's call it target position. Let's see what else. We also want a velocity, right? How fast should our enemy like move around? So let's do that. Velocity is a float, just like in our player script. So float velocity. And similar to how we generated the health here, we also actually want to generate like a random velocity within our limits, so to make the enemy like more dynamic. So let's do that. So private vector 2, we don't need a vector 2 int because the velocity is a float, so just normal vector 2. And let's call it a velocity range. And new vector 2, and the range of the velocity, I'm gonna say about from 3 to 6. So the minimum velocity of the enemy will be 3 and the maximum will be 6. Yeah. And so the next thing we want is a fly function, right? So similar to the player or the bullet, we want the enemy to be able to fly around. So let's do that. Void fly, right? So the first thing we need is actually like get the direction that we should fly to, right? So in our bullets we have current direction, which is here. In our player we have a direction, which is the input. In the enemy, we're going to get that direction through this target position, right? So let's do that. So vector 2 direction. And so the way that we derive the direction from the target position is this. We get the target position and we minus the position of our enemy here, which is transform that position, and then we normalize the vector. So basically like normalization, I think I talked about it in the first workshop, is that it would return like the vector that has a length of 1, which will represent a direction. So just normalized here. And it's giving me an error because transform position is actually a vector 3. So I need to convert that to a vector 2. And there we go. So we have a direction. And now that we have a direction, we can do the same thing that we did with our player and our bullet, which is rigid body 2D dot move position. So again, it will be the same thing, rigid body 2D dot position plus, and it will be our direction and times the velocity, and also times time dot delta time. Right, so we have a target position and we can move to that target position using rigid body. But okay, we times the velocity here, but what is the velocity? Because we didn't generate it yet. So let's do that in our generate function. Say velocity equals random range, and what will be velocity range dot x and velocity range y. Perfect. And so we have our fly function, so we should also call it in update because we always want our enemy to fly. And I think that should be it. So our target position here, we didn't set it to any position, so it will actually default to 0 by 0, which is like the center of the map, right? So if we go back to Unity, so it will default to the center of the map. So when we play, the enemy will actually move here to the center. So let me move the player out of the way so we can see. Move the player like here, right? Go to our game and let's play and see. And I think we're going to get an error again because I once again made a mistake of forgetting to actually assigning, making a reference to rigid body, but forget to assign it. So let's do it here. So select enemy and drag and drop it here. It's one of those things that I always forget to do. Anyway, so let's play our game and see if the enemy actually moved to our target position. So there we go. So we have the enemy move to the target position, and once it reaches that target position, it's just kind of hovering here because it reaches its target position. Is nothing else to do. So we need to generate a target position, and so once we start, we need to generate a target position, and also when we reaches our target position, we also want to randomize that target position again so that the enemy like move around. So let's make a function, call it like void randomize position. Right, so this randomized position will generate for us a target position, right? And it's actually like is quite similar to our generate function here, as in like we also generate stuff, but it's different because once we reach the target position, that target position will change and we will call this function, but we will not call generate because we don't want the enemy sprite to change in the middle of the game. So that's why we're having it as a separate function. So in order for us to actually like generate a target position, we actually want to know like what is the minimum position and what is the maximum position of the enemy. Like here, like when we generate a velocity, we know the minimum of the velocity and we also know the maximum of the velocity, so we can generate something in between, right? So just like here, we need to know the minimum position and the maximum position to generate something in between. So let's do that. Let's create a private vector2, and let's call it like min position. It's a new vector2, and it will be like minus 20 on the x-axis, so the minimum position will be like somewhere here and the maximum will be like somewhere here, so that we can generate a target position somewhere in between. So the x-axis and the y-axis will be both negative, and the maximum position, the x-axis and the y-axis will both be positive. So here, the x-axis, I'm gonna say 20, and the y-axis, I'm gonna say about 13. And we also want a maximum position. So max position, vector 2, vector 2, oh my god, vector 2, and 20 by 13. So it's the exact opposite of the minimum position. So now let's generate our target position. So the first thing, so let's generate a target position, right, equals new vector 2 here. So here we want to pass in a random x value and a random y value. So let's do that. Random. So I'm in the I'm generating the x value here. So random dot range, right, and it will be between the min position dot x and the max position dot x, right? So here we have it set to min position dot x is minus 20, and max position dot x is 20, positive 20. So when it generates, it will get a value in between minus 20, which is about somewhere here, and positive 20, which is about somewhere here. So we get something in between, just like that. And comma, now we get into the y position, or the y like random value. So it will be very similar to our x value. Random dot range. Whoops. And the minimum y value will be min position dot y, and max position dot y. And just like that, just like our x-axis, the min is minus 13, max is 13. So it will generate some value in between, right? And now that we have our randomized position like function, we can go to our start, and when we start the game, we of course want to randomize it. So randomized position here. Now in our fly, we want to check if the position of our enemy, right, of the position of our enemy like object, is it close enough to the position of our target? Like what do I say close enough? Well, because the position of the enemy, the x and y value, they are actually like floating point numbers. They're not integers, so they pretty much can't ever be the exact same value to our target position, even if we have the fly function that move our enemy to our target. So we need to check if it's close enough, and then if it's close enough, then we randomize the position again. So let's do that through a if statement here. If, and so how do we check if it's close enough? Well, what we can do is we can take the position of the target position, we minus the current enemy position, and we can get something called the magnitude of that vector. So here, for example, if we have the enemy ship and the player ship, we take the player position, we minus the enemy position, and then we take the magnitude of that value. We will actually get the distance between our enemy and our player ship. So that's what we're doing here. So if we have our target position minus the transform position, and again I have to convert it to a vector 2 because transform position is a vector 3, and then here we can say magnitude. So this will give us the magnitude, which is the distance between the target position and the actual position of the enemy. And we want to check if this magnitude is, say, like less than 0.1, right? So if this happens, it's close enough that we consider that we have reached our position, and we want to regenerate the re-randomize the target position. So here in the if statements, I'm gonna say randomize position, just like that. So now we randomize the position when we start the game. Let me go back to Unity so that it can compile in the background. So we randomize the position when we start the game, and when the target position is close enough to our transform position, which means that the distance, right, the magnitude or the distance is less than 0.1, then we randomize it again. So let's go back into our Unity, and no new references. Okay, good. And let's play the game and see our enemy movement to see that does it actually randomizes the position. So we see our enemy is moving, so it just changed direction very quickly. It's moving here. Let's see. Oh, there we go. It reaches its direction and it changed to it reaches its target position and it changed to a different position. Perfect. So that is the enemy movement. What we also want now is for the enemy to always sort of aim at our player, so always look at our player, and then we will have the enemy shoot a bullet random at a random interval. So let's do that. So first thing is we need a look at player function, right? So look at player here, right? And it will be very similar to our players look at mouse, right? So let's see. So going to our enemy, look at player. So similar to our player movement, we need a direction to look at, right? So vector 2 look direction, and that will be the player's position. So player.transform.position and minus the transform position dot normalized. Alright, so you might be confused as why do I say player here like we don't have a player references. Let's do that right now. So go in here, and now because the enemy will be spawned by a different script that we will talk about later, but the enemy will sort of not be in the scene, right? So what we want is when we start the game, we don't have any enemy. So if we make a reference to a player here, and if we make a reference here, if we add a field player and we drag and drop a player, that's not going to work, right? Because the enemy will not be in the scene when the game starts. So we need a workaround for that. So here, first we need a variable to hold the player, right? So how do we get the player if the enemy is not in the scene like initially? It will be spawned in, but it will not be in the scene initially. So what we can actually do is there is a function in Unity. So in our start method here, I'm gonna say player equals, and it will be find object of type. So what this will do is find object of type will look at our scene here and find an object that has the type that we will put here. So it will be player, right? Whoops, right, player, right? Player movement, yeah, that's our script, player movement. So it will look at our scene here, and this method will look at our scene here, and it will find the object that has a player movement script attached to it, which is our player, right? And we know for sure that there is only one object in our scene with a player movement script, so that's why we can use find object of type. So because it will only gonna return one value, which is our actual player. So now we have the look direction. So we just do the same thing with as we did in player movement, which is transform that the up direction of our enemy script will be the look direction. So now, this this function will make the ship always look at the player. So it will always take aim at the player. It's very good AI here. So we also want to call this in the update. So look at player, boom. And we go back into Unity. And we should see that when we play the game, we should see that the enemy will now always going to aim at the player. So when we run the game, so there we go. So it's moving around, but you notice that it's always looking at the player. As I move my player ship around, the enemy script is tracking me. Very good AI here. And you might also have noticed that our shadow position of our ship is not quite right because we forgot to actually fix it as we did in the player movement script here, right? So actually I'm just gonna copy this and put it here. So now that that is fixed, shadow dot transform position, and the reason that we have to say shadow transform position here is because here the reference to our shadow is actually a sprite renderer, not a transform. So here in our movement, the reference to our shadow is the transform type. So we get the shadow's transform component, but in here we actually referring to the sprite renderer. So we need to get the transform from that renderer. So that's why there's a little bit of we have to add that there. And also similar to our player that we're going to have health and max health, and we have take damage and die, right? So it will be very similar. So I'm just going to copy the functions because I am too lazy to type that. So copy that, paste it here, and So we have our enemy taking the damage, and we also have the enemy dying, right? So, yeah, that looks pretty good. And we also want our enemy to be able to like shoot the bullet, right? And again, we will do that similar to our player, but we will not be like shooting by like clicking on screen, right? So let's make a reference to our bullet. Public bullet. So this will be the prefab that we created previously, similar to our player movement. And go our scripts here, and we'll put it somewhere around here. Void shoot. And so it will be again very similar to our player's shoot function. In fact, I am once again going to copy the code and paste it, and we realize that we haven't made a references to our gunpoint. So let's do that here. Public transform gunpoint. Save that. Go into Unity. And so we recently made a change here that we want the reference to the public and the gunpoint. Of course, we need to assign that in our Unity editor. So enemy and bullet. So similar to our player, we're going to drag the bullet prefab onto our bullet field here, and we're going to drag the gunpoint onto our gunpoint transform. So, but now when we play the game, we will not see any of these behavior because we're not actually calling them. So, like, how do we want the enemy to actually shoot the bullet out, shoot the bullet from their point? Well, we want to do it on like a random interval, right? We want to shoot. We don't always want to like spam our player with we don't always spam our player with bullets, so we want to do it at random interval. So how do we do that? Well, first of all, we need to know like what will be the range between our like shooting time. That sounds so weird, but basically, like, how often do you want the enemy to shoot the bullet, right? Like every 1 second, every 2 seconds, or what? So we actually want this to be another like random variable, so that it's very dynamic. And so we're going to make a vector 2 for that. Let's see, let's call it shoot interval range, and it will be vector 2. And the range, the minimum of the range is, I'm gonna say about 1 second, and the maximum is 2 seconds. So the bullet will the enemy will shoot a bullet every 1 to 2 seconds or so. So it will generate a random value between 1 and 2 seconds, and it will shoot the bullet at that interval. So how do we actually do that? Like, how do we actually perform an action at an interval? Well, there is, I'm going to start here. There is actually like a function in Unity called invoke, right? And what this invoke going to do is actually it's going to call our function or method, which is shoot here, and it will call it with a delay like how many seconds do you want it to delay this call, right? So like here, when we start the game, if we call generate, it will do that right away, as fast as possible. But if we call invoke, and here I'm going to name it shoot, because that is the name of our function. It's very important that you put the right name here, because it's a string, so maybe you get it wrong sometime, and Unity doesn't notify you that you got it wrong, and you're just digging around finding what the error is. So the name of our function is shoot, and the time, you can see that the time is like the delay of invoking our method. So the time will be random range, right? Because we want to randomly shoot between either 1 or 2 seconds. So random range, and the minimum value is of course shoot interval range .x, and the maximum value is shoot interval range .y. Just like that. But now, if we do this, it's going to call the shoot function once at the start after this delay, and it's not going to call it again ever, because we only do it once here. So but what we want is for it to shoot and then wait and then shoot and then wait, right? That's what we want. So what we can do is we actually go into our shoot function here, and I'm going to copy this, and I'm actually going to paste it here. And what this does is, when we call the shoot here at the interval, it will call this one, and then this one will call another shoot function. It will basically call itself, like a recursion, and it will be a random interval as well. So, and then this one will also call itself again and again and again until our enemy actually die. So we can save that, go into Unity. I don't think that we made any new references. No, we don't. Okay, so we don't need to make any references. So wait for Unity to compile, and now when we play the game, we should see that the enemy will take aim at our player, and it will shoot a bullet at a random interval. So, shoot, yep, shoot, yeah, there we go. So we have our very basic enemy movement and enemy AI and the shoot functionality configured. The next thing to do is, of course, make our bullet actually collide with a player and collide with the enemy, so that we can damage a player or damage our enemy. So yeah, so that is what we'll be doing at next week's workshop. So this will conclude my content today for the third workshop. So feel free to ask any question if you have any.